Hello everyone, my name is Arnab Kr Borah and I welcome you all to our Mechanism Sessional Assignment-5. We have chosen the topic Windscreen Wiper Mechanism as our simulation assignment. This assignment is collectively done by Aditya Chari S, myself Arnab Kr Borah and Vishal Kumar. The problem statement is synthesize and make a simulator for the windscreen wiper mechanism. The contents that will be discussed in this video are as follows: Grashof criterion, displacement analysis, velocity analysis, acceleration analysis, force analysis, simulation of the mechanism, velocity and acceleration graphs, torque requirement, and variation of area wiped with length of input link. So first off, the Grashof criterion. The Grashof criteria states that in a 4-bar linkage, if the sum of the shortest and the longest link is less than or equal to the sum of the other two links, then the shortest link will rotate completely with respect to the other links. So in this given figure, O2A is the crank, which is the shortest link. Link O4C is the coupler and link CD is the support. This mechanism satisfies the Grashof criteria. Hence, O2A rotates completely about all other links. The motor is attached at the joint O2, which transmits power from input to output link, which is the coupler, hence enabling the windscreen wiper mechanism. Next, my teammate Vishal Kumar will be taking over from here.
Hello everyone, my name is Vishal Kumar and I will be explaining the analysis parts as mentioned in the contents. Starting with the displacement analysis. Displacement analysis gives the relationship between the input angle θ2 and the output angle θ4. The mechanism can be visualized as shown on the right side. Now taking A as the origin, we can write the coordinates of B and C as shown. From the distance formula, we can get the relationship between all the links. Now simplifying the equation using the half angle formula, we obtain the values of θ4 and θ3. Now moving on with the velocity analysis. Velocity analysis gives the relationship between the input angular velocity and the output angular velocity. Using Arnold Kennedy's theorem, we get the relationship between these two velocities. After simplifying the equations, we get θ4 dot equals Jacobian of θ2 dot. Now moving on to the acceleration analysis. Acceleration analysis gives us the relationship between the input and the output accelerations. Differentiating the equations obtained from the velocity analysis, we get the equations as shown in the slide. Now coming to the force analysis part, which gives us the output torque for the given input torque. The torque requirement for the motor can be calculated using energy conservation, that is, input power equals output power, and the power can be written as torque multiplied by angular velocity. From here, my teammate Aditya Chari will be taking over.
Hello everyone, myself Aditya. Now I'll be showing the simulation of the wiper mechanism and how it is done and explain the acceleration and velocity time graphs which are being attained and show the variation of area wide with change in length of the rock around. Here as we can see, we have approached this project in a very unique manner, such as we have used web development tools such as HTML, CSS and JavaScript's own custom libraries to attain this beautiful simulation. In this, we have used JavaScript libraries such as prairiedraw.js and sylvester.js and imported them in script.js for making this simulation as follows. We have also used Bootstrap 5 for improving the UI and UX capabilities of this website, such as this website is responsive across all mobile devices as well and across all laptop devices as follows. And this website has been implemented in Netlify's free hosting platform, as you can see in this video. And this website's code is also available in my GitHub repo, Aditya Chari 25, which is my GitHub username. And you can see the codes of the website and how this website has been implemented, a short description in README file. And this website's link and the GitHub repo will be shared in the YouTube description given below. And now we can start with the simulation of this mechanical session wiper mechanism, where when we start the simulation, we can see the velocity and acceleration time graphs, the real time graphs have been generated as follows, where the velocity peaks are attained when the acceleration is at its minimum, and acceleration peaks is being attained when velocity is at complete zero, 0 meter per second. And as you can see, the velocity is in the perfect sinusoidal form wave. And you can see we have initialized parameters such as 10 degrees for delta angle, wiper bar length as 4 meter, and for this you can see the area wide is 9.73 meters square. Now if I change the wiper bar length to say 2 meters, and if I reset and make it as 2 meters for this and start the simulation, we can see the area wide is becoming 4.87 meters square, which is almost half of the area wide for as for that of the length 4 meters. And as you can see, there is real-time calculation of speed, net acceleration, centripetal, and tangential acceleration, which is being calculated at a very tremendous speed. And this is being possible only due to the script.js library, where the calculation which has been explained by Vishal and Arnab has been implemented here as follows, using the JavaScript syntax and using its own libraries capabilities of Sylvester and PrairieDraw.js. And all this is being implemented only because of with the help of CSS. These things have been displayed in this website, and we can see the velocity and acceleration vectors as well. We can see there's a purple vector of the acceleration and velocity is green vector from the rocker arm, and from the motor arm as well you can see the velocity vector, which is always perpendicular to the arm's length. And we can see the code as well, where all the libraries have been implemented such as PrairieDraw.js and Sylvester.js. And you can see in index.html, where for every other calculation there is being a separate function which has been defined, such as where here the span id is acceleration underscore val, and script.js also you can find as acceleration underscore val in different functions, such as to display the real-time acceleration, such as the centripetal acceleration, the tangential acceleration in the website. And one can refer this website from the link given in the YouTube description down below as well. And yes, and this was our best effort from our side on this mechanical sessional project of Viper mechanism. And thanks for listening to us.